Hello, algebra students. This is our video on more equations practice. This is a great video for you to pause and try the problems as you go. And if you're getting them right, then you're good. You don't need to watch the writing out the math and unless you choose to. But if you're not sure how to do them or you want to just go ahead and enjoy and bask in the glory of watching the math being written out, then you go ahead and do that. For an entire year, this has been entitled Meow Equations Practice on my iPad, and I'm kind of regretting changing it back to more. It was just a silly typo. Pause it and enjoy the comic, but otherwise I'm going to go ahead and move forward and get started with the first problem. All right. Volume equals length times width times height. We're solving for h. This is a great example to go over because I want you to recognize here that when we want to solve for this h right here, the best way to do that is going to be to divide, and it's going to be to divide both of the variables I don't want off on both sides, making them both cancel out and leaving us h equals volume divided by length times width. So if I had a three-dimensional solid, a box of some kind, and I knew the length, and I knew the width, and I knew the volume, I could determine the height by using this formula, just to point that out. Okay, A equals B times the quantity C minus D. So we want to think about the easiest way to do this, and if we're trying to extract D right here, we are not going to do that by distributing. So don't distribute. Don't distribute. Instead, divide off that outside multiplied variable. Okay, divide that off. Please excuse the noise distortion for a moment. Sorry. Okay. So now I have A over B is equal to C minus D. And again, I'm solving for D, just to remind you, point that out over there. This is a little bit different. So what I'm actually going to do here is I am not going to subtract C from both sides. I'm going to add D to both sides. I want to make a situation where that D variable, the variable I'm trying to solve for, is positive. So right now I have A over B plus D is equal to C. And now I'm going to subtract A over B, leaving me with, and it's going to have to come up here, D equals C minus A over B. Now the reason I do this is that it's easier for me to solve for a positive D than it is for me to get a negative D and then have to simplify it, or fix it so that it's positive. And there you go. Let's do another. The Fahrenheit and Celsius temperature formula. We want to solve for C. And we can actually find that formula already solved for C somewhere. So we don't really need to do this. But hey, it's math. We're going to do it anyway. So I'm solving for C. I'm going to start off by subtracting 32 from each side. So the first thing we would do if we were converting from Fahrenheit to Celsius temperature is we would take the Fahrenheit temperature and subtract 32. Now I want you to think smarter, not harder. You're going to multiply here. Use your properties. You're going to multiply by 5/9. So to convert a Fahrenheit temperature into a Celsius temperature, you're going to first subtract 32 from it, and then you're going to take that result and multiply it by 5/9. And there you go. And now we're going to move back into just regular equations. So equation with variables on both sides. It's got a kind of an ugly situation here, distributive property and fractions all in one, and not everything goes evenly. So that's moderately unpleasant. Let's distribute. Let's get rid of the distributive property portion, which I could just get rid of the fractions first, but let's distribute first, and I think that might be an easier way to start. So negative 3/4 times x is negative 3/4 x. Negative 3/4 times a minus 8 is like negative times negative is positive. 8 times 3/4 is like saying 3/4 of 8. 1/4 of 8 would be 2, so 3/4 of 8 would be 6. Distribute here. Half of 6x is 3x, and half of 5 is 5.5. But I'm going to write it 5/2, 5 over 2. Now I'm going to get rid of my fractions. I'm going to multiply everything by 4. So that means 4 times negative 3/4 x, so negative 3x. 4 times the plus 6, so plus 24. 4 times the 3x, so that equals 12x. And 4 times 5 halves, which would come out to be, let's see, 5 halves of 4. Well, 1 half of 4 would be 2. 5 of those would be 10. Okay. Now I'm going to subtract 10 from each side. No, what am I talking about? What am I talking about? Come on, LeComte. Get it together. I'm going to add 3x to both sides. Of course, I could have subtracted 10 from each side, but I want to keep with the program. I want to keep with what I've been showing you so far because that keeps that routine moving forward, makes it a little easier to do. So I'm noticing now that this is going to come out to a pretty funkified answer. It's not going to give me a whole number at all. It's going to give me slightly less than 1, so if we divide by 15 here. Okay, and I haven't narrated the past couple of steps, but I think you catch my drift. 14/15 is the value I'm getting for x. So this is the part where being in the classroom is a big advantage for me. Hold that thought. Sorry, I'm back. Now the reason that I said that is that I have a graphing calculator with which I can check my answers. So I'm going to do something different. I'm going to take a quick picture of, and here it is my calculator screen here in the room. So I took my answer of 14/15 and I plugged it in for x. So negative 3/4 times the quantity, 14/15 minus 8. Now I did not put 14/15 in parentheses there because I know the calculator is going to divide and treat it like the fraction that it is. And then down here, same thing, 6 times that. And then look, both sides had the same result. So I know that's correct. And I'm going to move on to my next problem. Okay, here's another one. Negative 7 times the quantity d minus 2 is going to be, let's distribute, negative 7d plus 14. We have plus 18 after that. Negative 5 times 2d, negative 10d. Negative 5 times 2 is minus 10. Now, quick break here to talk about this real quick. Some of you are not doing this, and so as a result, you're making some mistakes. Remember to always look for places where you can combine like terms now, rather than only looking for what to add and subtract to both sides of the equation. Because in this case, if you simplify that, it now makes it easier. Generally, you want to see your equation all the way down to a variable term and a constant, and a variable term and a constant on each side at a maximum before you try adding and subtracting to both sides. Now that I'm here, though, negative 10 is smaller than negative 7, so I'm going to add 10d to both sides, giving me 3d plus 32 is equal to negative 10. I'm going to subtract 32 from each side. Give me negative 42 on the right. 3d is negative 42, and when you divide, 3 does indeed go into 42. It's a negative answer because it's negative divided by positive, and it's negative 14. Plug it back into the original equation and check it. And again, I have a calculator. I don't need a calculator to do this. It would be negative 7 times negative 14. Oh, sorry. Hold on. It would be actually negative 7 times the quantity, negative 14 minus 2. And then plus 18. So this is negative 7 times negative 16, which is 112. 112 and 18 ends up 130. On the right-hand side, negative 5 times 2, plug in the d value. So I'm just as efficient on paper as I am on the calculator. But one of the things I want you to recognize is you have to make sure you understand how to use that calculator to your advantage and use it correctly rather than typing things in incorrectly. Some of you experienced this on your most recent quiz and came up and asked about it. So that's something we should bring up when we're going over this in class, I think. All right, let's look at just the special cases and we'll be done with this video. All right, special case number 1, the good old identity, or the equation with an infinite number of solutions. So let's actually solve this one. Or let's attempt to, because as I just said, it actually has an infinite number of solutions, so we're not actually going to be able to solve it. 20f plus 8 minus 2f equals, let's combine like terms here, 18f and plus 8. And over here, 18f plus 8. And bam, that's where we have at this point, nope, something's wrong. It's identical on both sides. This is an identity. So the thought process is solve it the regular way that you usually solve it. And notice, Mayday, there's a problem. We have a true statement that's always true. And when I have a true statement like the one that I'm looking at, and maybe I didn't understand that that was a true statement yet. Maybe I had to subtract 18f to get 8 equals 8. That's another true statement we could get for this. Okay? Once I have a true statement, once I recognize that it's a true statement, that's when I know that this is an identity. And that the answer is actually all real numbers. Okay. Special case number 2. First, it sounded like I said special K, like the cereal. You know, the one with the berries. It's really good. So, distribute. It's actually probably not that good for you, though. Things like that. They pretend they're good for you, but I bet they're not. Okay, so I distributed. And I already noticed that I have a problem. 10A and 10A are the same. And then we got a 15 and a 2. That's different. All right, so let's say that we want one more step. Let's subtract 10A from each side, leaving me 15 equals 2, which it does not. We got a false statement, and a false statement automatically indicates that we are looking at a situation where there is no solution. There's no number that makes that true. You can write it no solution. You can write the null set. You can write the empty set. Oop, I missed. Got a little glitchy there with my stylus. Okay, so this empty, notice it's supposed to be curly braces. Just go with it. That empty set means no solution. There we go. The circle, the line through it means no solution. And then, of course, the words, the actual phrase, no solution. All right, guys, that's it for this video. We're going to be working on writing equations for word problems in class. Keep up the good work. I'm very proud of what I've seen so far this year. I'll see you in class.